Okay, now I'm going to be going over the rest of the study guide that doesn't involve the graphing rational expressions. So first problem, I have zeros that are at -1, 2, and 4 that go through 1, 8. So your polynomial expression should be y is equal to a, x plus 1, x minus 2, x minus 4. Because your zeros are at -1, 2, and 4, so that's these factors. And then all I do is I plug in the point 1, 8 to find my a. So it goes through 1, 8. So this is going to be a is equal to a. 1 plus 1 is 2. 1 minus 2 is -1. And 1 minus 4 is -3. So I get 8 is equal to 6a and 6. So a is equal to 4 over 3. I'm not going to go into the multiplication part of it. I think on the test I might not have you do it. But if you did do this and factor and multiplied everything, your answer should be this. And I don't want to spend too much time on this video going through it. I want to get to actually questions 3, 4, and 5, which I think more people have confusion with. So this is 20 over 3x squared plus 8 over 3x plus 32 over 3. Okay? That's what happens when you plug the 4/3 back into here. Now the second problem is a little more interesting because I have different multiplicities. So what I'm going to do is I have -1 with a multiplicity of 2, 1 with a multiplicity of 1, 0 a multiplicity of 2. So I know it has a 0 at 0, so I'm actually going to have a x and my multiplicity will be 2. Then I know I go x plus 1, and that has a multiplicity of 2, and x minus 1. So that's what your polynomial should look like. If you plug in all of the numbers, it goes through 272, the point 272. So this is 72 is equal to a times 4 times 9 times 1. And so I get 72 is equal to 36a. Divide both sides by 36. And I get a is equal to 2. If you actually multiply all of that out, I'm not going to go through the work, but you should get y is equal to 2x to the 5th plus 2x to the 4th minus 2x to the 3rd minus 2x squared. Okay, now I really want to go over 3, 4, and 5 because that involves a lot of the vocabulary and a lot of the concepts for this chapter. So, number 3, I have the polynomial function of f of x is equal to x minus 5 to the 3rd times x minus 4 squared. My zeros are 5 and 4, and the way I find the multiplicities is it's always the power of the factor. So I have a multiplicity of 3, since I have the power of 3 with my 0 of 5, and 4 has a multiplicity of 2. Now part B, I'm asking for whether it crosses or touches. If it's odd multiplicity, it crosses. Even multiplicity, it touches. So at 5, I cross x-axis, and then at 4, I touch x-axis. Then letter C is asking for the degree of the max number of turning points for this polynomial. Now, the first thing that I have to do is find the degree. And to find the degree, I just add the multiplicity. So I have a multiplicity of 3 and a multiplicity of 2. So my degree is I have a degree of 5. And the max number of turning points will always be 1 less than the degree. So if I have the degree of 5, my max number of turning points is 4. And then letter D is asking for the end behavior. Remember, the end behavior is, how does this look like when I get really, really large values of x? Well, what I notice is x minus 5 to the third times x minus 4 squared is really x minus 5 times x minus 5 times x minus 5 times x minus 4 times x minus 4. Now, the end behavior will always be the term, the highest degree term. Now, the highest degree term here is, if I do my multiplication, I know if I multiply the first two, my highest degree term will be x squared. If I multiply that to the next factor, which is x minus 5 here, my highest degree term will be x to the third. And there will be a lot of stuff added to the end of that. But right now, the first three, the highest degree term is x to the third. Then I multiply it by the fourth term, my highest degree term will be x to the fourth. And then if I multiply it to the last term, my highest degree term is x to the fifth. So here, my end behavior is x to the fifth. Now, number 4, we are going to do the same thing with a different function. So number 4, now I have negative 2 x squared minus 2. Now my zeros, you actually have 3 of them. A lot of you saw 1 and didn't know about the other 2. Most of you got that there will be a 0 at 0, since 2x squared is equal to 0. But now think about this. If I have x squared minus 2 is equal to 0, I get x squared is equal to 2, and I take the square root of both sides. So x is equal to plus or minus root 2. So I have a 0 at root 2 and negative root 2. Now, you might be wondering, what are the multiplicities of all of these? Well, the multiplicity of 0 is 2. That's easy. Now, what are the multiplicities of root 2 and negative root 2? Some of you might look at that and see it's a power of 2 and be like, it's a multiplicity of 2. But actually, remember, it's the multiplicity of the power. And remember, this is not factored all the way. X squared minus 2 is actually not factored all the way. Even though we haven't really factored something like this, we know what x squared minus 16 breaks down into. That breaks down to x plus 4, x minus 4. And if this was the case, I could say negative 4 has a multiplicity of 1, and 4 has a multiplicity of 1. So what I'm actually going to do here is break this up into 2x squared, x plus root 2, x minus root 2. It's just a variation of the difference of squares where I just take the root of 2. And so you see my zeros of negative root 2 has a multiplicity of 1, and positive root 2 has a multiplicity of 1. Now part B is asking whether we touch or we cross. So 0, since it's even, at 0 you touch, and then at plus or minus root 2 we cross. Letter C is the maximum number of turning points. Now, what is my degree here? Well, if I add all my multiplicities up, it's 2 plus 1 plus 1. I have a degree of 4. And so my max number of turning points is 3. And then letter D, I'm going to do here, what is my end behavior? Well, it's the highest degree term. If I multiplied this out, my highest degree term would be 2x to the fourth. So my end behavior is 2x to the fourth. Or sorry, negative 2x to the fourth, since there's a negative there that I didn't see. So that's your end behavior for that question. Now, number 5, my function here is 4x squared plus 1 x minus 2 to the third. Now, there's no x here, so there's no 0 here. X squared plus 1 is equal to 0. There will never be a 0 here, right? Because I can't take the square root of a negative number. So my only 0 is 2, and it has a multiplicity of 3. And I know that I'm going to cross x-axis at 2. Then letter C, my max number of turning points. Now, here, you actually have a degree of 5. I know what we usually do is we add multiplicities, but when you add multiplicities, you actually are supposed to add all of the complex roots too. Since we don't do the complex roots here, just actually look that this is x to the third, and I have x squared. So my degree here is 5. And then, so my max number of turning points is 4. And then what does my end behavior look like? Well, if I have x squared and I have 3 of these terms, it's actually going to be x squared times x times x times x. That's x to the 5th. But I have a coefficient of 4, so my end behavior is 4x to the 5th. Okay. Okay, now, number 6. 6 is actually just like 1 and 2, except we do it from a graph. If you look at 6, I have zeros at -4, -1, and 3. So for number 6, your polynomial should be y is equal to a, x plus 4, x plus 1. But look what happens at -1. So if you look at your graph, at -1 you touch. That means I have an even multiplicity. And I tell everyone, just this is not an exact equation. If it crosses the x-axis, just make it exponent of 1. If it touches, make it an exponent of 2. So I'm going to make this 2, and then it's going to be x minus 3. I know it goes to the point -8, 1. So the way I'm going to do this is -8 is equal to a, and then this becomes 5. 4, since 1 plus 1 is 2, 2 squared is 4, -2. And I get -8 is equal to -40a. And so a should be 1/5. And if I plug that back in, I told you could just leave it in factored form. So it's x plus 4, x plus 1 squared, x minus 3. So that's number 6. Number 7. Is the same thing as number 6. I have how many zeros here? I have 1, 2, 3 zeros. I have 2 that touch, 1 that crosses. It crosses at 0, so that's a multiplicity of 1. And then it's going to cross both at 3 and -3. So it should look like this. And then if I know it goes to the point 2, -50, so it's -50 is equal to a times 2 times 25 times 1. 2 plus 3 is 5 squared is 25, so I get -50 is equal to 50a. And so a is equal to -1. So my equation of the function should look like that. Okay, now we'll jump to the back, the inequalities. I think most of you have understood how to do the inequalities. So let's actually see the inequalities done for you. And actually, number 14 is actually a repeat from the homework. So I did that one in class. So I'm just going to do 12 and 13. 12, it's x minus 2 squared over x squared minus 1 is greater than or equal to 0. If I factor this, this is x minus 2 squared, x plus 1, x minus 1 is greater than or equal to 0. Okay. And then so I have to take the critical values of everything, the top and the bottom. The bottom will be an open dot, so I know I'm at -1, I'm at 1, and I'm also at 2. Open dots at -1 and 1, and a closed dot at 2, because it's greater than or equal to. So what's going to happen is I need to test my points. If I plug in -2, okay, I'm going to have, so if I plug in -2, the top is -2 minus 2. So if f of -2, it's going to be negative squared over negative times negative. So that's positive over positive. So this is positive. If I pick a number like 0, so f of 0 will become negative squared. This will be positive times a negative. So overall, this will be minus. If I pick a number like 1.5, this will be negative squared over positive times positive. So this is positive. And then if I pick a number like 3, everything will be positive. So this is positive as well. So I'm looking for when it's greater than or equal to 0. So that is all of my positives. So my answer here is all x such that x is less than -1. Why less than? Because I have an open dot there. Or x is greater than 1. Okay? Since both of these intervals, I could just say greater than 1 and it takes care of the last interval too. And in number 13, I have 5 over x minus 3 is greater than 3 over x plus 1. Oh no, I was looking at the wrong one. So 13 is 3x minus 5 over x plus 2 less than or equal to 2. I have to make it the inequality less than or equal to 0. So this is going to become 3x minus 5 over x plus 2. Minus 2 is less than or equal to 0. I have to find a common denominator here, which is x plus 2. So this stays the same since that has a common denominator already. And I'm going to multiply the second term by x plus 2 so that I have a fraction, or a fraction with a common denominator there. This becomes 3x minus 5 minus 2x minus 4 over x plus 2 is less than or equal to 0. The top then becomes x minus 9 over x plus 2 is less than or equal to 0. So now I could do my number line, and I'm going to have -2, 9. And now let's plug in all the values. -2 open dot, 9 close dot. If I'm at 10, everything's positive, so that's positive. If I pick a number like 0, I'm a negative on the top. and I'm positive on the bottom, so this is negative. And then if I pick a number like -3, negative on top, negative on bottom, so I'm positive. So I'm looking for the ones that are less than or equal to 0. So it's this middle section. It's going to be all x such that -2 is less than x is less than or equal to 9. Don't get the signs mixed up. Open dot is less than, and the closed dot I have to put the equal to. Okay.